Okay. Okay, now we proceed to the next learning standard. Okay, in this learning standard, okay, you must know how to determine the relation between three or more variables for a given joint variation. Okay, so what is a joint variation? Okay, what is a joint variation? So from the previous example, you know that you only have one-to-one relation, right? Okay, now, okay, we know that. Okay, the definition for joint variation. Okay, for a joint variation, y varies jointly as x power of m and z power of n. Okay, it varies more than 1. Okay, so look at here. Okay, y varies directly as x power of m, z power of n. This is the variation relation form. Okay, if you convert it to the equation form, the same thing like the previous one. Okay, this symbol you will change into equal, and then there is a constant k. Okay, so we look at the first example. Okay, P varies, okay, P varies directly as Q and square root of R. Okay, that's it. Okay, and then equation form is P is equals to KQ square root of R. Okay, B, y varies directly as the square of w, so w square, and cube of x, so it is x cube. Okay, change it into equation form, it will be y equals to kw square x cube. That's it. Okay, C, the volume of a prism V varies directly as the area of a cross section A and its height h. Okay, so in the equation form, V is equals to KAH. Okay, finally D, the mass W of a cylindrical metal rod varies directly as its length P and the square of diameter D, so D square. So we change it into the equation form, W is equals to K PD square. Okay, as simple as that. Okay, we look at the next example. Given that x varies directly as y square z, okay, express x in terms of y, and z if x equals to 6 when y equals to 3 and z equals to 5. Okay, so okay, I write it first. Okay, x varies directly as y square z. Okay, change it into equation form. X is equals to ky square z. Then, like the previous one, okay, we need to find the value of k first. Okay, by substitute the given value of x, y, and z. Okay, so x is 6 equals to k, y is 3 square, z is 5. Okay, from this value, you can get k is equals to 6 divided by 3 square 5. So k is equals to 2 over 15. Okay, so the answer is x is equals to 2 over 15 y square z. Okay. Okay, next example 11. The gravitational potential energy E joules of an object varies directly as its mass m kg. The gravitational acceleration, okay, and its position at a height of h meter from the ground. given that E equals to 197 joules when M equals to 4 kg, G equals to 9.81 and H equals to 5 meter. Write an equation that relates EMGH. Okay, so we know that E varies directly as MGH. Okay, so we change it into equation form. So E is equals to constant K mgh. Okay, next find the value of K. Okay, by substitute the values of E mgh given in the question. Okay, so from the question, E is 197 equals to K, M is 4, G is 9.81, H is 5. Okay, so K is equals to, okay, you calculate, you will get 1. Okay, so we know that E, okay, is equals to mgh. Okay, where is the K? The K is 1. Okay. Okay, next, example 12. Okay, three quantities STU vary as shown in the table on the right. It is given that S varies directly as T and the cube root of U. Cube root, okay, of U. Calculate the value of X and Y. Okay. So change this relation into equation form. Okay, so S is equals to K T cube root of U. Okay, then you use the information from this first column, okay, in order to get the value of K. Okay, so S is 6 equals to K, T is 0.8 and cube root of 27. Okay, so you calculate, you press your calculator. So K, you will get 2.5. Okay, so okay, hence we know that S is equals to 2.5 T cube root of U. Okay, so next, okay, we want to find the value of X. Okay, so by using this formula, so S is equals to 2.5 T cube root of U. Okay, so S is actually X. Okay, so X is equals to 2.5, T is 1.2, cube root of 125. Okay, so press your calculator. So you will get the value of X is 15. Okay, the same goes to Y. Okay, so S equals to 50 is equals to 2.5, T is 40 and cube root of Y. Okay, so cube root of Y, okay, you press your calculator, you will get 0.5. Okay, so to get the value of Y, so you need to cube both sides. Okay, so 0.5 cube, you will get 0.125. Okay, so I hope my explanation is clear. So if you have any problem, you can just rewind this video and try to understand and look back one by one. Okay. Okay, so for this self-practice 1.1c, okay, I want you to do it by yourself and submit it into the Google Classroom later. Okay, so you have to do number 1, number 2, number 3, number 4, number 5, number 6, number 7 and number 8. Okay, I think for each of the question, okay, the problem is just the same like the example. Okay, so you can refer back to the example, okay, in order to answer this self-practice 1.1 C. Okay, we move to the next learning standard. Okay, solve problem involving direct variation. Okay, so look at example 3. Okay, Charles' law states that for a fixed mass of gas, the volume V centimeter cube of the gas is directly proportional to its absolute temperature T Kelvin if the pressure of the gas is fixed. It is given that a container of 30 centimeter cube of gas at a temperature of 30 degrees Celsius. Okay, A, express V in terms of T, and B, calculate the volume in centimeter cube of the gas if the temperature changes to negative 11 degrees Celsius. Okay, so how to solve this problem? Okay, so first of all, okay, we need to understand the problem. Understand the problem. Okay, from the problem, okay, it is given that V is directly proportional to T. Okay, and from the question itself, okay, we know that, okay, when V is equals to 30, okay, sorry, V is equals to 30 when, okay, T is equals to, okay, 273 plus X Kelvin. Okay, this is the conversion. Okay, you need to know that. Okay, next. Okay, we need to have a strategy. Okay, so devising a strategy. Okay, first, okay, what we need to do. Okay, so first we need to, okay, write the direct variation in the form of equation. Okay, this is the first thing that we need to do. Okay, the second one, okay, substitute the value of T into the equation and hence calculate the volume of the gas. Okay, okay, the third one, okay, the third part, okay, we implement our strategy. Implementing strategy. Okay, so we know that, okay, we have V is proportional, directly proportional to T. Okay, so we also know that, okay, V is equals to KT. Okay, where our T is actually 273 plus x. Okay. So from the question, okay, v is equals to 30. Okay, this part 30, 30. Okay, so 30 is equals to k 273 plus 30 degrees Celsius. Okay, so k 30 divided by 303, and we will get 10 over 101. So we can conclude that v is equals to 10 over 101 t. Okay, so settle part A. Okay, then B. Okay, calculate the volume in centimeter cube of the gas if the temperature changes to negative 11 degrees Celsius. Okay, so V is equals to 10 over 101 273 minus 11. So V is equals to 225.94 centimeter cube. Okay, and our final strategy, okay, is making a conclusion, where the answer of the first part is V is equals to 10 over 101t, and the answer of the second part is V is equals to 25.94 centimeter cube. Okay, so this is actually step by step. Okay, what you need to do in order to solve this problem involving direct variation. Okay. Okay, so for example 14, okay, I want you to try yourself, okay, with the same strategy. Okay, if you follow step by step, okay, I think you will easily get the answer without any problem. Okay, so next same goes with the self-practice 1.1D. Okay, I want you to do number 1, number 2 and number 3. Okay, so for this class you have 3 assignment. Okay, so self-practice 1.1B, 1.1C and 1.1D. So you have 1 week time, okay, to finish all this question, okay, and submit it to me in Google Classroom. Okay, so if you have any problem, okay, during your the process of finishing this assignment, you can just WhatsApp me. Okay, as usual, no problem. Okay, I will try to help you. Okay, so that's all for this class. So we have finished the first part, okay, 1.1. Okay, 1.1 direct variation. Okay, so for the next class we will look into inverse variation. Okay, so that's it for today. So thank you very much. Okay, don't forget to fill in your attendance form. Okay, bye, see you next class.